Question number 4. The diagram shows the forces acting on a block resting on an inclined plane. Okay. The angle theta is adjusted until the block is just at the point of sliding. Okay. At the point of sliding, which means what? The object is not sliding. It is about to slide. Very important to note. Okay. So which means what? You have something like your, it's about to slide. It's not been sliding over here. Okay. R is a normal reaction. W is the weight of the block. F is the maximum frictional force. What do you mean by maximum frictional force? When an object, see, if you plot a graph of the frictional force versus the applied force, then what do you see? You get a straight line like this, goes to your peak and then it comes down and then it goes like this here. What do you call this point as? This is your F max. What do you mean by this F max? This is your limiting friction. That means what? The maximum force that you will be able to apply so that the object can slide. Okay. Now what is he asking? What is the maximum coefficient of static friction between the block and the plane? Okay. So how do we do this now? Cancel this, right? So therefore, if W is acting over here, the component of W along this direction should be W cos theta, and along this direction should be W sin theta. So how do you get this theta? How do you get this W cos theta? If you ask me this question, then you see I can show it to you briefly. Okay, this angle is theta. Okay, let me redraw this one here. So this angle is theta. This angle is theta. The block is kept here. So weight is acting like this over here. So W. So this angle is 90 here. If this angle is 90, this angle should be 90 minus theta, right? This is your R here. Now this R is perpendicular to this line. This line and this R are perpendicular to each other. So what I will do is I will draw the line, extend this line like this over here. If I extend this line, so what will happen is this whole angle is theta, right? Which angle is theta? This angle is theta, right? If this angle is 90 minus theta, if this angle is 90 minus theta, then what should this angle be? This angle should be theta, right? So therefore, now you have a situation like this is your W acting like this. You have one line like this over here. You have another line like this over here. Okay. So this angle is theta and this angle is 90 minus theta. Okay. So therefore, what is the component of W along this direction? W cos theta. What is the component of W along this direction? See, since I use here W cos theta, here also use the same one. W cos of 90 minus theta, right? So I just take W into angle between this line and the weight over here, which should be equal to W sin theta. This we have got this, right? So W sin theta is like this, but the force is exactly opposite to it. So what I will do is I will now write this as, F is equal to W sin theta. We go back and show you F is equal to W sin theta, and then your R, which is R here, this your R is equal to W cos theta. R is equal to W cos theta. So if that is the case, now what do we have here? For whenever it crosses the static friction, then we can write this as mu L limiting multiplied by R is equal to the frictional force, right? So what I can do is I can write mu L into what is R here? W cos theta is equal to W sin theta, right? So this W and this W goes away. So what am I left out? Mu L is equal to tan theta. So what is being asked? Maximum coefficient of static friction, which is nothing but your limiting friction. Thus your limiting friction coefficient is equal to tan theta. C is the answer.